We are go over discussion week 4, page 56, question number 3. It's asking to identify if they are a pair of enantiomer, diastereomer, methyl compound, or identical. Yes?
I think that on the left, that chlorine should be a dash.
Oh, a dash.
Yeah.
Oh, okay. Keep writing the wrong question, okay? It doesn't work. Okay, chlorine. Yeah. Okay, so both case have something in common, which there are 6 membrane. One way of doing this would be you just view as it is. Okay, I know it could be hard for some people to view. Okay, if I write the other side, I'll show 2 ways of doing this. Okay, we're looking from the front side and we think they're dash in. But if you imagine you're viewing from the other side, okay, the compound is still going to be the compound. Now it's being joined in this way where this one is dashed in. But if you're looking from the other side, this one should be wedged out. Can you imagine that? It's like your compound is here. Now you're looking from this side. Okay, what if I look from this side?
Yes.
Can people imagine that?
Yes, it's like just.
Okay, it could be a little bit hard. So that's why I'll introduce 2 ways of doing this. Okay. Okay, if you're viewing from the other side, okay, like now the dashed in methyl, okay, let's imagine this blue is the methyl. The blue methyl was dashing in, now become wedge from if I'm viewing from the back side. And this dashed in chlorine, okay, this red chlorine is dashed in. Now it's from wedged. Okay, keep in mind, but it's just like the compounds you're viewing. This blue and red is both dashed in from your side, but now I want to draw them from my perspective. They're not wedged. Yeah. But the difference would be, okay, keep in mind the blue is methyl. The chlorine was the red was chlorine. Keep in mind it was on this side, but when I want to draw this, they flip. Are we cool with what we're doing? Mm-hmm. Okay, some people cannot imagine this, but we will have other ways. But I'll show this way first, which are people good with chlorine is wedged out, methyl is wedged out, but when I draw it the other way, yes, they are in a different direction. Are people good with that? Cool. This is exactly the same as this one. Yeah. Are people good with this? Okay, we'll do the same thing for this one. Okay, both bromine is wedged out. Okay, this blue bromine. Okay, this blue bromine. Red bromine. Okay. Okay. Imagine that's a ring. Blue bromine and red bromine, they're wedged out, right? Yeah. Okay. It's from your side of view, right? Yeah. Okay. Now I want to redraw them from my side of view. From your side of the view, it's wedged out, right? Okay, from my side of view, it's dashed in. Yeah. Okay. It's dashed in. Are we good with what we're doing? Yeah. Okay. Then why is this one identical? Well, this one, isn't this identical? Like it's the same thing, right? Okay. Something we haven't learned in the class. Yes. Yeah, but you do have learned that in your discussion, which is if there's a symmetrical plane, yeah, it's methyl. Okay. But I do want people to practice with viewing. Okay, if I was viewing them in the other side. Are we good with what we're doing? Yeah. Okay, this is one way of doing this. The other way of doing this, draw the chair conformation. Do people want to try that? Okay. Okay, the chair conformation of this one, chlorine, methyl.
Thank you.
Okay, bye. Right? Are we good with that?
Yeah.
Okay. We'll do the ring flip. Your chlorine and methyl. Did we set the when we do ring flip? Okay. When we do ring flip, all your equatorial group will become axial.
Yes.
Okay. Chlorine become axial. This one become axial. It's a methyl group. So that's the same as this one.
Oh yes. After flip, they are.
Yeah. But this is the other way of doing this. Okay. Add-on question. Who is more stable?
This one.
This one. Because both bulky group is in equatorial.
Yeah.
Okay. Are we good?
Okay.
The same for this one. I guess I don't need to draw them out, right?
Yeah.
Are we good? Yes.
Wait, sorry. What was the point of writing it in the chair conformation?
If people cannot see, they're exactly the same.
Okay.
Because all your equatorial become axial. This one was dash. It's ring flip. It's the same compound. In case people cannot see why it's the same compound. Are we good?